Good day, students. In this clip, we're going to be going over how to apply the parallelogram method in resolving vectors, and we'll go over an example on vector components, and also finding the magnitude and direction of a vector. Okay, so let's take a look at geometric resolution of vectors first. For question one, we're going to find the resultant vectors geometrically using the parallelogram method, and then verify the accuracy of our results arithmetically. Okay. All right, so for number one, we're going to be considering the problem vector p plus 2s uh, plus q. Okay. All right, so let's go ahead and place our coordinate system on the tails of each vector to get our orientation together, because that's where we're going to be starting from to determine the coordinate form of each vector. Alright, so there goes our coordinate system on each tail. Alright, now we're going to go ahead and find out the value of the representation of each vector in coordinate form. So we just need P, S, and Q in this problem, so let's focus on those. Vector P is, let's see, 1, 2, 3, 3, 6. Vector S is -4, -2, and vector Q is 3, 1. Okay, starting from the tail, counting to the tip. 1, 2, 3, up 1, and this one 1, 2, 3, 4, down 1, 2. So okay, S is supposed to be -2. All right, now that we have our coordinates, we need to graph them. So for this problem, we just need vector P. Vector P, we already know what it is. Vector P is simply 3, 6. And then we need 2s. Remember, if you have a coefficient of a vector other than 1 or negative sign, you have to distribute that coefficient or the negative into the vector first before you graph. Okay, so since they have a 2 here, we must double vector s. All right, -4, -2. And then we'll double that, we'll have -8, -4. So this is what we're going to be graphing. All right, and then we have vector q. Vector q is just a positive vector, so we're not going to change it, do anything to that, just 3, 1. All right, now let's go ahead and find the geometric resolution of these vectors using parallelogram method. So just to set up our coordinate system, we notice that for the x's, the x coordinates, it goes as high as some of these, which is uh, as far to the right as 3. And then for the y's, it goes as high as 6 and as low as -4. Okay, so if we centralize our coordinate system, the y, shift it to the right a little bit, and then make the x-axis a little bit higher, because we know we're going really low to -8. All right, so something like this should suffice. All right, now first thing we're going to graph is vector. We're going to do the first two, p plus 2s. So let's graph vector p and label it. So vector p will go to the right 1, 2, 3, and go up 1, 2, 3, 4, 5, 6. So this right here, this is vector p. Okay. All right. So for the quiz, I want you to draw the vector with the arrowhead, and you have to label it. Okay. Labeling is not optional here; it's required to get all your credit. So you have to put the arrow of the vector, and then you also have to label your vector. So this is vector p. All right. Now let's go ahead and label graph the next one, 2s. So 2s is -8, -4. So we go 1, 2, 3, 4, and then we're gonna go. All right, let's go ahead and graph 2s, which is -4, -8. So we're gonna go to the left, 1, 2, 3, 4, 5, 6, 7, 8, and then go down 4, 1, 2, 3, 4. All right. So there goes vector 2s. Let's draw that in red. So this vector right here, this is vector 2s. to the tip, and we also have to label it. All right, this is vector 2s. Okay, next thing we're going to graph is we're going to use the parallelogram method to find out what the sum of these two vectors is. Okay. All right. So what I'm gonna do, I'm gonna translate p to the tip of vector 2s, or we can translate 2s to the tip of vector p. Doesn't really matter. So if I translate p to the tip of vector 2s, so starting from here, I'm going to graph the vector directions of p. So starting from here, I'm going to go to the right 1, 2, 3, and up 1, 2, 3, 4, 5, 6. Okay? So go to the right 1, 2, 3, and up 1, 2, 3, 4, 5, 6. All right, and then now let's draw vector p. We're going to use a dotted line because this is the translation of vector p. Okay, it's not actually vector p from the origin. All right, so that's vector p translated. And then we're also going to draw a vector 2s on the tip of vector p using the direction of 2s going down. All right, so this is a parallelogram, and our resultant vector will be the vector we get when we graph from the origin or the tail of the two vectors to where the tips of the translated vectors meet. Okay, so let's go ahead and graph that. Let's make that blue. All right, so going from here to here, I'll bring colors to that again. Blue. All right, so going from here to here, that's vector p plus 2s. Okay, so let's go ahead and label that. This vector right here is p plus 2s. P plus 2s. We're not done yet. Okay, so what do we do next now? We're going to add vector q to vector p plus 2s. Okay? All right, let's go ahead and do that. All right, so vector q is 3, 1. So let's go ahead and graph that. So we're going to go to the right 1, 2, 3, and up 1. All right, so let's go ahead and graph vector q. I'm going to graph that in green. All right, so let's go ahead and graph vector q. So from here to here is vector q, and let's label it so we don't get confused. So this is vector q. Now we're going to create a parallelogram using the resultant of p plus 2s and vector q. Okay, so I'm going to translate vector q to the tip of 2s. So to do that, I'm going to use the directions of vector q, the coordinate numbers. So I'm going to go up 1 over 1, 2, 3, right there. And then let's draw the translation of vector q onto the tip of vector p plus 2s. I'm going to use a dotted line because this is just a translation. It's not the actual vector q. So it goes from there to there. All right, and now let's complete our parallelogram by drawing the translation of vector p plus 2s on the tip of vector q using the direction of p plus 2s. Okay, so there you have it. Let me change the color to blue. All right, now we draw the diagonal. That will be our final result. Okay, so let's go ahead and draw the final result. So we're gonna draw the vector from from the origin to where these two tips meet right there. Okay, so there goes your answer. This vector right here. Let's see. Left. This vector is vector p plus 2s plus q. Okay, p plus 2s plus q. So now, what are the coordinates of this vector, this resultant answer? We're going to go to the left, 1, 2, which is negative 2. And I'm going to go up 1, 2, 3, negative 2, comma 3 is your final answer. Now this is the answer geometrically using the parallelogram method. Now let's do it using the numeric method, okay? Numeric method. Hopefully we get the same answer, which will confirm that our answer is in fact correct. Alright, so numerically we just simply find the combination, arithmetic sum of these vectors. So we have p is 3, 6. Vector 2s is negative 8, negative 4, negative 8, negative 4. And vector q is 3, 1. So you just add everything straight down, and that will give you your final answer. Do everything at once. So let's do the x's first. So negative 8 plus 6 is negative 2. 6 minus 4 is 2. 2 plus 1 is 3. Does that match what we have up there? Absolutely. This is what we had up here. This is what we have down here. So our answer is in fact correct. All right. So that's that. All right. Now number 2, we're going to be finding the magnitude, finding the components of a vector. So let's go ahead and write this down for number 2. We are to find the vertical and horizontal components. The vertical and horizontal components of the given vector. Okay, of the given vector. All right. So this is a vector under consideration. Let's say we have a vector acting in this direction. This is a force of 33 newtons. Force of 33 newtons is acting at an angle of 20 degrees to the horizontal. So let's draw a horizontal. Let's change that to this format. So let's draw the horizontal again. So this is the horizontal right here. Now let's say that this vector is acting at an angle of 20 degrees to the horizontal. Okay, so we have to find the vertical and horizontal component. So this is 20 degrees. Okay, so this is going to be what our triangle will look like. This piece right here, this would be the vertical component, and this would be the horizontal component. All right. So if this is the angle under consideration, will be the opposite, and this will be the adjacent. All right. So let's label them. So this will be vertical component, v of x. I'm going to call this v of x because I want to call this 33 Newton force is called vector v. Okay. So this will be the component of this 33 Newton force, and this will be the y component. Actually, this will be the up and down is y. This will be the y component, and this will be the x component. Okay, horizontal and vertical of this force. Now remember the formulas. Remember that the y component has the opposite on it. Okay, opposite and SOHCAHTOA, and then the x component has the adjacent. Okay, and they've been expressed as a function of the hypotenuse. Okay, so what trig ratio is depends on opposite and hypotenuse. That's what the vertical component is. All right, and then the horizontal component is what trig ratio relates the hypotenuse and the adjacent. All right, so let's do vertical horizontal first. V of x. V of x is going to be vector v. Now, if you think about adjacent and hypotenuse in SOHCAHTOA, which one has adjacent and hypotenuse? Which one relates this to? Is cosine, right? So v of x, the horizontal component, is going to be the hypotenuse, cosine, the angle, okay, theta. This is the general formula. And then the y component is relating the opposite and the hypotenuse. So it's going to be so it's going to be the vector v sine theta. All right, so there you have it. All right, now let's apply that to this formula to this problem. So in this problem, we know that v of x is going to be the vector v, which is 33 newtons, cosine the angle, which is 20. All right, so let's find out what the approximate value of that is. We got our calculators. So we're going to compute. I'm going to compute 33 cosine 20. And the answer is 31.0099. Okay, so uh, horizontal component is 31.0099. 31.0099 newtons. And then the vertical component, V of y, is going to be 33 sine. Okay, sine 20. Let's put that in our calculators. I'll have 33 sine 20. And our answer is going to be 11.2867. 11.2867. 11.2867 newtons. Okay, so vertical, let's write out what this answer means. Vertical component of the force is the force in the y direction. It's 11.2867 newtons. And then the horizontal component is the one along the x, right? Horizontal component of the force is going to be 31.0099 newtons. You can see that we have a greater force in the in the x direction because the angle is less than 45 degrees, okay? All right, so there you have it. All right, so for number 3, we're going to be finding the magnitude and direction of the given vector. So number 3, write down the instructions. Find the magnitude and direction of vector, let's call it vector v. Okay, and this is the situation we're looking at. We have a vector broken down into its components. So this is vector v. It's broken down into its vertical and horizontal components. So let's see. This is vector v right here. And we have the situation that the y component is 7 and the x component is 4, and it has a direction of alpha, which we also have to find. Okay, so first thing is, how long is this vector v? That's what we have to find first. Okay, so let's go ahead and find the magnitude. All right, so how do we find the magnitude? Well, since we have horizontal and vertical components, the angle of separation between the horizontal and vertical lines is 90 degrees, right? So we have a right triangle here. So we can use the Pythagorean theorem to figure out the magnitude of vector v. Okay, so using the Pythagorean theorem, we know that this side right here, this is your opposite, right? Because it's opposite the direction. This is your adjacent, and this longest side right here is your hypotenuse. Okay, so we can either use a squared plus b squared plus c squared, or we can use a trig version of that, which is that h squared, the hypotenuse square, or c squared, is equal to a squared, the adjacent square, plus the opposite square. Okay? Alright, so the hypotenuse square is the magnitude of your vector, which is the magnitude of vector v square equals a square, the adjacent, which is the x component of the vector 4 square, plus the opposite square, the y component of your vector, which is 7 square. Okay? Now let's work this out. So we're going to have, this is going to become 16 plus 49. And then when we add them up, we'll have 65. So the magnitude of vector v squared is 65. So we read both sides, read the left and the right. And then we have the magnitude of vector v equals the square root of 65. Can that be reduced? Let's see if we can break that down. 65 ends with 5, so I can take out a 5. 5 goes there 1, 5 goes to 15, 3. This is a prime number, hence it cannot be reduced. Okay? So we know that the magnitude of vector v, magnitude of vector v is square root of 65. Now we need the direction. Okay, what does the direction mean? What is the direction of the vector? Well, the direction of the vector is the angular measure from the horizontal, right? Alpha. Okay. So since we know the measure of the opposite, which is 7, and the adjacent, which is 4, which trig ratio are we going to use in SOHCAHTOA? Which trig ratio relates opposite and adjacent? It's the tan, right? TOA. So we're going to do this, use this trig ratio to solve for alpha. Tan of the directional angle, alpha, is equal to the opposite, which is 7, over the adjacent, which is 4. Okay? Alright, so if we can isolate alpha, that will be the direction of the vector. So how do we get rid of tan is the question. We use the inverse tan, right? We take the inverse tan of both sides. So inverse tan of tan alpha equals the inverse tan of 7 over 4. So on the left side, these two cancel out. So you have alpha equals the inverse tan of 7 over 4. We can plug that into our calculator. Let's go ahead and do that. Inverse tan of 7 over 4. And the final answer is 60.2551. Okay, so alpha is 60.2551 degrees. All right, so let's write that down here. The direction of vector V is 60.2551 degrees. All right, so there goes our two results for the magnitude and direction of vector V as shown in the diagram. So thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel by clicking up here. And if you like this video, you can click like. And please post a comment to let me know what you think about this presentation. And more clips can be found on mathgurdserve.com. Thanks again, and have a wonderful day.